Hello friends, welcome to Now You Know channel. In this tutorial, we are going to implement tree data structure. A tree data structure is used to store, retrieve and search information efficiently. In this tutorial, we are going to discuss the below points. Number 1, defining a tree data structure. Number 2, implementing operations like inserting a word, searching for a word and starts with prefix, which returns the list of words that starts with given prefix. Here is a representation of a tree data structure after adding certain words. Here I have added 6 different words. They are ant, appeal, apple, bug, bus and bunny. As you can observe, the root node holds the first character of a given word for insertion, which is again a node which holds the next available character in the given word and so on, which is again a node and so on, until there are no more characters left for an insertion. Let's see how to define data structure which supports this kind of representation. Here I have already created a class, the main class Trie, which I have defined the operations like insert, search and autocomplete. There is a default implementations are just given, so let's not worry about that one. So let's worry about defining a data structure. So here I am going to introduce a class. I call it as node, and within that we are going to introduce a variable private hashmap of key type a character. The value type is a node, the same node. Fine. So we call it as a chain. I'm just going to instantiate new hashmap. Yeah, that's all. Yeah. So that's the end of defining a data structure for this representation. So let's see how this particular definition supports this kind of structure. So here there is a root node which I am going to introduce in the main class. So private node, which I say root, which is an empty node. Yeah. So when a word is given for an insertion, then the root node changes the first character as a key and the node as value. The node contains a chain variable again. The node contains the chain variable again, which is a hashmap again, which takes a single character as a key and the node as a value, which is again contains chain and so on. So with this we are good with the definition of a node for this representation. So within this node class we are going to introduce 3 different core methods which are very helpful while doing the actual operations here. So let's say public void add, so which it takes a single character as an parameter. So what it does is this dot chain dot put the given character, which is C, and assign a new node as a value. So next method is public boolean contains the given char. So we simply return this dot chain dot contains key C. So we are going to introduce one more method, which is get character C, and this is going to return the node for the given character, chain dot get C. So with this we are done with the core methods, and let's see how the insertion logic to be written. So here when a word is given, so we are overloading one more method which I am going to call insert word, and I'm passing the root node. Let's create this one. So we are our approach is a recursive approach. So we should have a base condition. So the base condition for our logic is if the word is null or word is empty, then return from that point. Otherwise, so check whether the root node contains the given the first character of a given word. So I'm not going to call this as root, but I'm going to call it a node. So as I said, first check whether the node contains the first character. Contains. So I'm going to hold the first character in a variable which I call first word dot char at 0. If the node does not contains the first character, then we simply add. After adding, after adding, so we are going to iterate with the rest of the words, which is insert word dot substring from beginning first index, and I'm going to, after adding, we are going to get the next node we just added, node dot get first. So with this we are done with the insert method. So I hope you're getting the logic. So here I have created an insert recursion tree for word apple. So here the apple will be sent in this. Let's see, we are sending the apple comma the root node here. So first the root node doesn't contain any chain. So then when the root node doesn't contain any chain, we are just adding the first element to the root chain. So after that we are going to iterate with the rest of the characters remaining in the, after removing the a, like pple and the root and the node a instead of root. So we are not sending the root again. So that is the reason we are doing node dot get first, so that we can send eighth node, this one, with pple. Since eighth node doesn't contains p, just add it and just iterate with the rest of the words, which is ple. And again the p doesn't contains the p chain, then add it to the p and then iterate with le, and so on. So after e there are no more characters left. So at this point we hit the base condition, which is this one, and from that point we are just returning the execution. So what I'm going to do is I'm going to insert some of the words here. Trie dot put insert, which I'm going to do Sheldon Leonard Utrapalli Howard. So I'm going to put a debug pointer here and hit debug, so to see how the root node looks like. Fine. So just hit the debug button. I hope you understand this recursion cycle and the logic what we have written here is same as what the recursion tree shows. Let's wait the debug point to appear, so that we can inspect the root variable and what it contains. So you tell me what the root node contains. The root should contains a hash map, which is a chain, and that contains that should contain the size 4, and it should contains the keys S, L, K, H. So we got the debug point here, and we are just inspecting what the root contains, which is a root. Root means this variable, and it has the chain in it, so which is this chain. I'm just exploring. So what are all it contains? Yeah. So we got the first characters, right? Sheldon, Howard, Kutrapalli, and Leonard. So let's explore the Rajesh Rajesh is a Rajesh, not a Rajesh actually. The Howard. Howard is smallest word among all these. So let's explore Howard. See. So the chain is created for a H and the value is node again. So which again has a chain with key O W, and the chain is keep nesting with the rest of the chain and keep coming H O W A R D R and D. After D there will be no more entries, so node will be empty, so the chain is empty here. Yeah, so we got the chain is empty. Similarly for the rest of the words like Sheldon, Leonard, Kutabali, Howard, it's the same way. So how we just explored, right? So it should be the same way. S H E. Yeah, that's it. So with this we can conclude that insert is working very much fine. So let's do a search operation. How the search operation looks like. So here again we are going to check the base condition, which is I'm going to return false instead of sorry, this returns a boolean, right? So this particular search return type is boolean. So word is null or empty. In that case we are going to return false. Otherwise we again overload this method word with root. Oh sorry, boolean. It should be a boolean. I'm going to call it node. So here we are taking the first character and we check whether the node contains the first character. Here I'm going to introduce a variable first equal to word dot char at 0, and if node dot contains the first does not contain the first, then return false. See, the first character, we are just extracting the first character and we are checking whether node contains that first character. I mean the chain, whether the chain is contains for the given character. If not, we simply return false. Otherwise we are iterating for the rest of the words. Word dot substring, index starts with 1 and node dot get first. So I hope you understand. We are taking the first character and we are checking whether the chain is present for the first character for the given word. If not, then we are simply returning. Otherwise the node contains, otherwise we consider the node contains the first character, then we are just simply extracting the first character, evicting the first character from the word, and we are getting the chain of the given first character. So here I am going to return. So the base condition here is, so we have not yet added the base condition. The base condition looks exactly like this, but instead of returning false, it is going to return true. So I will show you how this search works. So first the root, after inserting the apple, we are trying to search apple, whether the apple word is present in the tree. So first we are sending apple with the root. The root checks the first character whether it is present in the chain. So it is present. So it is evicting the first character in the given word and giving the next chain, which is A in this case. So similarly we are chopping the first character and iterating with the rest of the word. Similarly it checks whether P is present in the 8th node. It is present. Then iterate with the next of the road and by calling the next get of P. So similarly it is keep iterating until there are no more characters left. So if we hit the end of the chain, then it means I mean, if there are no more characters to search, no more iteration is possible. So that is the base condition. This is our base condition, right? If it is empty, then we return true at this point. So we are going to test with certain examples. With try dot search, I'm going to say, I'm going to pass Penny and Leonard and Leon. So you should tell me now. So this should return false expectedly, and this should return true. Again, this should return true as well, because Leon is a substring of Leonard, right? So let's debug this. We should get false, true, true. Yeah, false, true, true. So our search operation is also working very much fine. And then let's start implementing starts with or autocomplete. Yeah, I hope you understand the recursion tree of search and the logic what we have written here, right? Yeah, let's understand how autocomplete works. So autocomplete takes prefix as an argument, and which returns the list of words which starts with a given prefix. So for that, I'm going to introduce a method in the core class, which is public hashmap. I'm going to return the chain of the node, which is a character type of key, and node, well, get chain. So I'm not going to pass any variable there. So we simply return new hashmap with this dot chain. So I'm returning new hashmap with the chain because we don't want to mess with the original hashmap, which is a chain in this case. So here this is required. We'll come to know why this is required. So for starts with. So first thing first. We just need to check the same condition. Okay, in this case, prefix. Words. Otherwise, if prefix is not null and not empty, so I'm going to overload prefix, the same method, prefix with words, and I'm going to pass the root node, which is root in this case, and I'm going to pass the prefix again. I'll let you know why we are passing the prefix again here. So which is returning the list. We should return the list. We're going to create this method. So I'm going to call it original prefix. Instead, I'm going to call it original. Okay. So here, what I'm going to do is I'm going to get the chain of the up to the end of the last character given in the prefix, which is the similar logic what I'm going to implement here. If so here this means, so we already checked this null or empty in the original autocomplete method, but here I'm checking the same condition, but instead of this here if we hit the bottom means we are done with the chain of the prefix characters. So here we need to populate. For the time being, I'm just returning null. So let's iterate up to the last word in the given prefix. If not, I'm just going to check this dot. Sorry. I'm going to call node. If node contains first character, so prefix dot caret 0. If the node does not contain the first character, then there is no need to further iteration, right? So from this point we are going to return words. Otherwise, we are going to call again with the rest of the words. Substring starts from 1 and words as it is I'm going to pass as it is, and from here I'm going to get the next chain, which means in this case it is present, then we are going to get the next chain, which is I'm going to call first, and the original I'm passing as it is. I'm going to say return. Yeah. So here what I'm trying to do is, like, we are getting the chain of the last word present in the prefix. So after that we get the node. We are going to recursively iterate the chains that are present in the node. I'm going to add in the dictionary, which is words. So here, so we are done with the prefix words. We get the node at this point. So what we are going to do is we are going to introduce one more method, populate words with original prefix with node and words. So let's introduce this one. Yeah. So here I'm going to check the another condition. If node dot get chain dot size equal to 0, then what we are going to do is words dot add original. So these are base condition for the recursive approach. So these actual operation at this point that we are going to implement. So which is node dot get chain. I'll explain in the slide so how this works. So what I'm going to do is, for each I'm going to call subnode on the character C. So what I'm going to do is I'm iterating the whatever is present in the chain, what are the values present in the chain, which is basically hash map. Hash map holds the certain values which is pointing to other nodes. So I'm just iterating it, and I'm calling the same method, populate words, by appending original plus C and subnode comma words. And then at the end I'm just returning words. So here I have, for an example, how the starts with works. So here is a root node which has a appeal and appeal. So when we pass AP to the starts with, APP to the starts with, so what it's going to do is we are getting this node, and we are just iterating every possibility that contains in this chain. So this is the logic for that. So iterating it, and we are just appending this P to the original prefix, which is APP in this case, and it's going to append the L, and iterating with E next time with Eth node. So it is going to append E also once to the original word. So we hit hit the base condition again here, which is node.get chain dot size 0 0. The node chain size for E should be 0 in that case, because there are no more chain added to the E. So from that point, we are simply adding it to the words, which is a list in this case. So after we are done with every possible chain or the APP, so we are simply returning from that point. So let's see with by testing it. So trie dot trie dot autocomplete with HO. So I'm going to say sys out. It should return the list of words that starts with HO. So before that, I'm going to add some more words. Howard, Holland, holiday, and house, hall, HAWLL. Okay. So one that starts with HO, one starts with H. So here I'm expecting to get Holland, not in the particular order I'm mentioning here. So basically we should get Howard, Holland, holiday, and house. These are all words that starts with HO. So for autocomplete that starts with H, we should get one more, which is hall. So let's test this one. Yeah, we're done with it. Okay, so here as expected, we should get Holland, holiday, Howard, and house when we pass HO to the autocomplete method. So similarly, when I pass only H, so all the words that start with H should be present in our dictionary, like this. So with this we conclude that our autocomplete is working very much fine. So that's the end of the video. So before going, we just need to understand the autocomplete logic once again, if you are interested. So I'm just gonna explain one more time. So with this example, see here what we're doing is the root node. I'm just passing autocomplete with the APP and with the root node. So here, so I'm not explaining this basic condition, but I'm explaining this one. Okay, so we are actually trying to get the last element up to the last character present. We are trying to get the node. So A is present, we iterated A, and P is present, we got here, and P is present, and we got here, and there are no more characters present after APP. So we return, we got the node, and we just need to iterate every possibility of the pth node. So there is a reason we are just iterating every possibility. I'm just appending to the original prefix with the iterated character, and I'm just updating the node as well. Whenever we iterating, I'm just updating with the next available node, and we're just passing words whenever there is no more chain there are no more chain present, then we are going to add it to the words, and at the end we're just returning the words. So that's the end of the video. Thank you for watching. Thanks for your time. Bye.